Now I am taking the factors affecting the induced EMF and the current. So I will tell you that what factors affect the induced EMF or upon which factors this induced EMF depends. So magnetic flux, linked with a coil of n turns. Now this phi B is equal to BAN cos omega t. This we know. Phi equal to BA cos theta. So in place of theta we can write down this omega, the angular velocity. The magnetic flux can be changed by either way, either by changing the magnetic field, area, number of turns, and by rotating the closed surface. So induced EMF E equal to minus d upon dt phi b. So this E is equal to minus d upon dt and phi b is what? BAN cos omega t. So this is equal to this BAN omega sin omega t. This is the induced EMF. And now you can see from here that clearly, first induced EMF depends upon magnetic field. So what we have, this E is proportional to B. Higher the strength of magnetic field, higher is the induced EMF. Second, induced EMF depends upon area of coil. It means that this E is directly proportional to area of the coil. Larger the area, larger the induced EMF. And now third, induced EMF depends upon number of turns in coil. It means that this induced EMF is directly proportional to N. Number of turns. Larger the number of turns in the coil, larger will be the induced EMF. And now fourth factor. Induced EMF depends upon angular frequency or angular velocity. angular velocity of rotation rotating the coil. It means what? That this E is proportional to omega. And we know that this omega is equal to omega. This is equal to 2 pi n, and the frequency n equal to frequency. So larger the value of omega, more will be the induced EMF. It means that we are having the four factors upon which this induced EMF depends: the magnetic field strength, area of the coil, number of turns of the coil, and the angular frequency. Suppose the coil is rotated in the magnetic field, then this induced EMF is maximum. And also when the plane of the coil is perpendicular to the magnetic field lines, then this induced EMF will be greatest. And you can see from here that this omega t equal to pi by 2. So when this plane is perpendicular to the magnetic field lines, in that case this B will be the plane of the coil is parallel to the magnetic field lines. In that case this will be, because we are always taking this angle with the normal of the coil. So suppose this is the magnetic field line in this way and the coil is in this way, then the normal of this coil will be in the direction of this magnetic field line. So omega t equal to 0. But when this coil is rotated like this, so the surface of this coil becomes parallel to the induced of the magnetic field line, then the induced EMF is maximum. And you see from here that this induced EMF does not depend upon the material of the coil. Induced EMF does not depend upon material of coil or the resistance. R. Because R is not coming in this relation. So whether the coil is made of conducting or non-conducting material, in both kinds of the coil, there will be the induced EMF. The induced EMF always exists in conducting and non-conducting material of coil. तो coil का मटेरियल कंडक्टिंग हो अथवा नॉन कंडक्टिंग हो, दोनों में ही इंड्यूस्ड ईएमएफ होगा। तो अगर आपने coil लकड़ी की बना ली, even there will be the induced EMF, but induced current नहीं होगा उसके अंदर। तो induced current exists only when the coil is made of conducting material. induced current. This I is equal to E upon R, Ohm's law. Ohm's law. So this E is equal to B A N omega sin omega t upon R. This is equal to I. It means that induced current depends upon this magnetic field area, number of turns, the angular velocity, and also the material of the coil. Clearly, the induced current depends upon magnetic field, B, number one, magnetic field, B, number second, area of coil, A, and third, number of turns, N, and fourth, the angular velocity, omega, and fifth, the resistance of coil, resistance R of coil. So what we see, that this I is proportional to B. This is what I have told you, this one, and second, this I is proportional to A, and third, that I have written here, number of turns, I is proportional to N, and now fourth, angular velocity, I proportional to omega, and fifth, the resistance, I is proportional to 1 upon R. It means that the induced current depends upon the material of the coil. If the coil is made of non-conducting material, then there will be no current at all, but there will be the induced EMF. So, for a coil of conducting material, I is not equal to 0. I is not equal to 0, and induced EMF E, this is also not equal to 0. But for coil of non-conducting material, this I is equal to 0 and this E is not equal to 0. This is what the difference between conducting and non-conducting. In non-conducting, nothing is 0, both will exist, but in case of non-conducting material, I will be equal to 0, but E is not equal to 0. Induced EMF is not 0. So, this is what the difference between the induced current and the induced EMF. So, non-conducting material are so many, are there? Conducting material. This is like your copper, aluminum, iron, gold, silver, and that the alloys, etc. and alloys like your brass, Constantan, nichrome, etc. In case of non-conducting material, non-conducting material are which, like your paper, wood, paper, plastic, rubber, diamond is not conducting, but the graphite is conducting material. Etc. So if the coil is made of this conducting material, then both will exist. Neither I nor E is equal to 0, and here this I is equal to 0 and E is not equal to 0. So in case of non-conducting material, there will be the induced EMF but not the induced current. In case of non-conducting material, the resistance is approximately infinity, so I will be equal to 0. So this is about the dependence of the EMF and the current. This is maybe set the questions that what is the material. If suppose the coil is given of non-conducting material, then whether there will be the induced EMF or not, or if there will be the induced current or not, then you can answer to this question. So remember that in non-conducting, in case of conducting, the current is not equal to 0. It means that there will be current, and E is not equal to 0. It means the induced EMF will be there. But in case of non-conducting, there will be no current at all, but there will be the induced EMF. So these are the factors upon which the induced EMF and the current depends. So thank you very much.